Good afternoon, students. Am I audible to all? Yes, may I audible?
Yes, sir.
So, we have already seen all basics of ANOVA. Okay, so that you can just try to understand, and I hope you have started write it down these notes on your notebook. And the last class we have done the estimation part, where we have estimated the parameter, which is your mu hat, okay, and alpha hat. So that two estimated value we did. Now we try to find out their estimated standard error. Okay? Estimated standard error. So how to get that estimated standard error? Once you have computed the value of mu and alpha. Okay. So the procedure is very simple. As we have seen, the error sum of square can be defined. It is summation of double summation eij square, and that eij become the yij mu minus alpha iga whole square. But if I use hat here, because estimated error sums, if I use hat here, everywhere hat will come in picture, right? Everywhere hat will come in picture. So it's become mu hat minus alpha high hat the whole square, right? And now this is square, so you may use like this. I can write twice. That is I will say a square into b square. Okay, a square into b square. So one can use that formula. Now after that, you can simply open the brackets, multiply this yij with this term. Similarly, mu hat with this term, and alpha hat with this term. Means just go on multiplying with the each term with this brackets. Okay. So if you just multiply this first term with these brackets, you can understand this is this steps. Minus mu hat into this summation, minus alpha hat I square, alpha hat I into this summation. Okay. And giving summation to each term. Can you look at though both summations will be given, because this is in bracket, this is the whole bracket. So these two summations are given to each term. And now we have to understand this steps very importantly, because if you done mistake here, then whole thing goes wrong. So how you can deal such a technique, whether what it is going to be, is it going to be what? So they have written it is nothing but 0, and this is also 0. So how this comes, that is the question is there in our mind. So we have this is summation, double summation yij minus mu hat into alpha I hat. This is the basically over the range of I over the range of j, right? We have this is the formula. If I substitute this value, mu hat value, so that what is the mu hat value we have obtained? That is the, what is the formula for mu hat? Can you look at? This is y bar dot dot. Okay, that is y bar dot dot, and alpha value, alpha will be nothing but y I dot minus again y bar dot dot. So this value is nothing but y bar dot dot minus in bracket y bar I dot minus y bar dot dot. Correct? And if you just substitute these values, can you look at what is that actually? What is this actually? Minus minus plus. and this is the minus, so this will get cancelled. What is remaining? What is remaining? Correct. Over the range of I, over the range of J. And if I just consider, open the brackets, what I will get here? What should be that? Can anyone tell me what is going to be this? So this is over the range of I over the range of J, y I J minus summation over I, summation over J, y I dot J. What is this? Notice this. Can you understand? J is independent. J is independent, right? So J is running from where to where? It is what? This is Ni, right?
1 to Ni.
Yeah, Ni, and this is yi dot. I think bar I forget. But what is summation of this part? Or what is actually this part? Double summation Yij. What is this?
Grand total.
Grand total. But how you deal this? And then what about this one then? What about this one? Because they have written it is 0. That means if you just substitute these values, what is this values actually? What is this value actually? So may I write in terms of this, in terms of I will say something called the summation K format. What is this? Just look at here. Just look at here. See the formula for y bar I. What is the formula given for y bar I? Can you look at this into this? What is that? Summation over j is running from ni yi j. So what? So what? This I will be replacing by, or this I will be, so this quantity will be replaced by what? Summation over j y I j, and this is we have summation over I j y I. So we got this term become 0. Are you getting my point of how it is turns out to be 0? Yes. Anyone? Any
So will you
question?
please explain again, sir?
See, you substitute the value of mu hat alpha, right? So
Yes.
no problem at all here. Whatever the terms are you getting here remaining, put it. Open the summation sign. Give the summation to each term. Okay? Once you give the summation to this and this also, this summation can't do it anything. But if you just give the summation to this one, since it is independent of j, okay, so it will be ni, and this y bar as it is. But what is this ni y bar? क्या है आपका? Summation over j.
Ti bar. Ti dot.
Correct. So 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 this I will be say this portion is nothing but summation over j yi j, and we have already I here. Therefore, this is So this is something like a minus a. So answer turns out to be 0. Is that clear? So
Yes, sir.
you will be get the second term and the third term become 0. Second term and third term become 0. Okay. So you are left with only the first term. And once you have left with the first term, you can just so similarly as you did it for second part, you can do it. Try for the third part. This particular summation is also turns out to be 0 only. Okay, you can just work on. You can get it that answer. And now you have the first term. Open the brackets. Again 3 terms. The summation Yij mu hat summation Yij into summation over I alpha I summation over j Yi. So what is this step? This is your grand total, right? Grand total. What is this? This is the treatment total, not mean. Don't forget. This is treatment total and alpha I as it is. What is a mu hat? Y bar dot dot. This is same. So I'm not repeating that. This is same. So mu hat is nothing but y bar dot dot. What is alpha hat? This should be had. They have not written properly. This should be had. Okay. Just make correction. So mu hat is nothing but y bar I dot minus y bar dot dot into t I dot. Now, what is this? Y bar dot dot grand total upon capital N, right? So keep it same. What about this step? Again, open the brackets. So y bar I dot into ti dot minus y bar dot dot into ti dot. Okay. Now after that, you can just look at this step, which is important. This is become multiplied, so it will be get the grand total square. And what is this y bar I? You know the formula. It is the ti dot minus divided by ni. Similarly, this is the grand total. Okay, so g upon n. Now this you can simply so this step will be as it is. So that I'm keeping as it is. This is ti square ti dot square upon ni minus this is the independent, so you can pull out into summation ti dot. Now, if you take ti dot over the range of I, what is that? Is it grand total? What is ti? What is ti dot here? Is it nothing but summation over j yi if you gone through notes properly?
Yes, sir.
Yeah. So so if you take summation like if you substitute this value will be here over the range of I over the range of j, it is become grand total. And if you just multiply g with g, you'll be get g square. So e hat we got it here, this particular term minus this particular term. Okay, and usually this term is known as total sum of square. Known as total sum of square, and this term is known as I will just make a little bit here correction. It is uh, sum of square due to treatment. Okay, so don't use this. This is due to treatment. Okay? Just make that correction in your while writing the notebook. Okay, even I'm just going to upload this video maybe later on, so you can just you can use that notation. This in the simplify I will be called TSS. Okay, total sum of square, and this will be SST. Okay, so SST become sum of square due to treatment, and TSS means total sum of square. Okay, so don't get confused between these two terms. So sometime we can use like TSS is equal to SST upon SST plus ESS. So don't get confused between those terms. Okay. So I may use that now notations maybe later on. So this is TSS, that is the absolutely right, and this is SST. Okay. So just make that correction SST. I may go with the same notations like treatment sum of square ऐसे भी जा सकते हैं, but I feel that there is a small change you can do it because the if you just look at the standard book, okay, they may use this term sum of square due to treatments like that. Okay, so you can go about it. So this is also SST also can be written S squared suffix to treat, means it's S square sum of square due to treatment. This is the first one is a sum of square, that is a total sum of square. Second one is your treatment sum of square. Okay, you can just remember. And if you are willing to take the error part, it will be the difference of these two parts. So error kya hai mera now in this case? This minus this, that is called error actually. Okay. So this is the basically, and g square upon, and you already knowing, right? If I cancel this, if I just open the bracket, this will be get cancelled, and we are left with this minus this. Okay. And on the basis of that, one can able to obtain the values of uh, like ESS. Yeah. Any question? Any question so far here? So this is the way you can always compute error sum of square, and now we have to show that st square is equal to this particular quantity, means you know now notation. St square means total sum of square is nothing but this, and what you have to show that your total sum of square is nothing but this quantity. Total sum of square. Okay. Like, okay. So just go through these notations. This st square or tss is nothing but this term. So if I'm just using this notation yij minus y bar dot dot, is that equivalent to this term or not? That we want to show, right? So whether this is equal to this or not. So it's very simple, I think. No need to explain nothing. It's very simple. You can just open the brackets. You just open the brackets, right? So if you just open the bracket, see here I have not applied it a minus b ka whole square, because that middle term is going to be zero. Middle term is going to be zero. So that's why that term becomes zero, and we have the first term and the last term. Okay, and so you can just understand how this works. Double summation yij square minus 2 times double summation yij minus y bar dot dot plus double summation y bar dot dot square, right? So we have this term and we have this term. This term becomes zero. Why it is zero? Because if you just look at this quantity, what is this quantity? No, sorry, this is not zero. What is this quantity? Can anyone tell me what is this quantity? Or what about this quantity? How we can do such a quantity? How you can write? Yes, anyone? What about this quantity? This is independent, so you can pull out minus 2 times y bar dot dot. What is this quantity? Grand total. Again, this is independent. So y bar is a independent. But what about this quantity? What is this one? N, right? And now what about this one? What is y bar? It is summation yij upon n, right? So if you multiply, or I can add g upon n.
सर
What about this into this?
में इंटरनल वन है पता है
Sorry? May I audible to all first of all? Let me ask you this question. May I audible to all or
Yes,
no?
sir. Yes.
So this is 2 times y bar dot and this is the grand total. But what is the grand total? N into what? N into y bar dot dot. So minus 2 times y bar dot dot into n into y bar dot dot plus n into y bar dot dot square. What is this? 2 times n y bar dot dot square with minus sign plus n into y bar dot dot. So 2 times a plus a. What is that? 1 time a. So from these steps to these steps, we have these many steps, which is not covered because this is a standard result. So when we have a like y minus y bar ka whole square with summation over I, one can directly write summation over yi square minus n into y bar square. That is a standard result. So that's why they have not written this all. They can go with like directly. So after this step, they have written simply because they independent hai, then we can write yeah. So this double summation into n into y bar dot dot square. But what is the grand total? You can write g upon n, which is the usual definitions, and then you can just simplify it. You may get this expression, which is equal to st square, which is the left hand side. So you can just look at it. It's very simple. You can only the major thing is that from this step to this step, how do you? And that is the standard results. So one can use standard result, or one can just do. If you're not able to remember, you can simplify it as usual, applying the a minus b ka whole square. Similarly, you can do it this one also. Again, this is nothing but your SST. So whether you can just apply it and you can just show it like with the help of 1 2 steps. So I'm just skipping that. Similarly, one can do also this one. So that is that part I can skip it. Only thing is that after doing this part, they have just adjusted this term here. Add and subtract. So see, how do you like from these steps to can get like can simplify. So this is not because this the s square e we have already shown the difference of this minus this. Okay, that is we have already shown. So that's why I'm just skipping that part, which you can do it very simply. Only thing is that you need to add here these two values, which is like addition and subtractions, and these terms become your like SST. This is equal to TSS minus SST. Okay, treatment sum of square minus sorry total sum of square minus sum of square due to treatment, and hence we can prove it. Have you clear with this or not? Tell me first. Because that is a very important part, because that is all basically a simple derivations one can just like when you write it down, you will be understand thoroughly. Then we have to talk about little bit degree of freedom. Okay, we have to talk about little bit degree of freedom. So how you can calculate the degree of freedom? That is the important task. Okay, so if I talk about the total sum of square degree of freedom, total sum of square degree of freedom. So total we have n observations. Total we have n observations. So if we have n observations total, and I am just putting one condition here, y bar dot dot, which you need to be compute. So that is called a linear constraints. Okay, so based on that constraints, there is a one linear constraints we are putting to compute this total sum of square. So that's why there is a 1 degree of freedom can be reduced. So therefore the total sum of square having n minus 1 degree of freedom. Okay. Similarly, we have a sum of square due to treatment, sum of square due to treatment. Okay, which can be computed since we have a k independent values, or I can say k treatments. So obvious there are the k equations. So if there are the k equations, therefore the degree of freedom can be, see, as we have n observations here, as we have n observations here, similarly we have a k treatment there, right? And we are putting that one linear constraints on that. What is the conditions? Y bar dot dot. So again we are computing, that's why it is the k minus. It is the k minus. Right? And once you know that, these two degree of freedom, one can very easy to find out remaining degree of freedom, which is this minus this, which is n minus k. So you can just look at here, you will be get it is the n minus. So knowing the total and one thing, one can find the remaining thing. Okay, so that is the way you can always find the degree of it. Now there are preliminary results means you can just have the recap of that, like y bar. So this is your model. This is your model. Y bar I, you already knowing that. Substitute these values here. So you will be get this. This is what? Just divide this all. What is this? Summation over j and I independent. N I and I get cancelled. Left with mu. What about this quantity? Again, it is independent. So n I and I get cancelled. Alpha I. But what about this quantity? It is dependent on j. And you know when you take summation over j, it's become dot. So E bar I dot. Right? And why it is bar? Because you've divided by Ni. So you got y bar I dot is nothing but mu plus alpha I plus ei dot. E bar dot. Sorry. E bar I dot. Now you consider y bar dot dot. As you did it for y bar I dot, can you do it for y bar dot dot? This one. Same way. क्या मिलेगा? Can you tell? Anyone tell? क्या मिलेगा? And get cancelled, remaining with mu. But what about this quantity? It's over the range of I, over the range of j. So over the range of I or j is independent. So ni alpha, we have put it as 0. We have put that one assumption. Ni alpha I becomes 0. And what is this? E bar dot dot from assumption, right? Because you are dividing by over the range of I over the range of j. So that is a grand error. So we can get E bar dot dot. Now, once you have that quantity, you got y bar dot dot, you got y bar I dot. Okay. Now you can consider this E bar, EI bar. What is EI bar? EI bar, sorry, EIJ follows normal mu 0, mean is 0, and the variance is sigma square. That means they have written like this. So what is it? E bar, EI bar. What is the formula? EI dot bar. What is the formula? Summation over J EIJ upon Ni. We have seen this, right? ये formula हमने कहाँ से पढ़ा है? यहाँ से पढ़ा है, right? ये this we have seen like E bar I dot. So what could be their expectation value? Can you find the expectation value? If you just take expectation of this value, that means actually I'm trying to understand if my EIJ follows normal with mean 0 and variance sigma square, then what could be the distribution of E bar I dot? What could be their mean ka like I will be say like error mean, or you can say mean. I mean that's a part of mean only. So what could be the distribution of this? तो क्या करोगे? You need to find expected value of this. Expected value निकालो चलो. E निकालो. Take it out constant summation of EI because Ni is independent. So pull out. Can you look at expected value of EI is 0. So mean क्या हो गया? 0. Can you find variance? Again Ni independent. Take it out. Variance of EI sigma I square, sigma E square, right? And since it is independent, so Ni EI square. So finally we left it. So what we found the result, if my EI follows, what is the result we got now? What is the result? We got it here. If EIJ follows normal mean sigma, mean 0 and variance sigma square, so E bar I dot follows normal with mean 0 and variance E sigma square upon Ni. Are you getting the point? Yes. Are you getting the point?
Yes, sir.
Any questions so far? Anyone? Please let me know. Please let me know. If you can, like, if you are facing any problem, please let me know. Now, similarly, you can work on E bar dot dot. Exactly the same way as you did for E bar I dot. Similarly, you can work on E bar dot dot. I think you will be get the same results, but slightly change in that result. What is a slightly change? Can you look at? Can you look at? Whole procedure is same. So if EIJ follows normal with mean and sigma square, so E bar dot dot follows normal 0 comma sigma E square upon capital N, because it is E bar dot dot, right? Both are dot. So both are dot matlab kya? What will be their addition? Total observations capital N. But here EI dot, तो इसका डॉट का एडिशन क्या होता है? Ni. So Ni will. So just understand in this way, like you can understand properly this way. Okay. Any question for E bar I? Let me know. If you have any questions, then let me know. Yes, students. Yes, tell me. we go ahead? Why there are very less students? You'll be get your result today, but the timing will be 2 to 4, na? Now we have to show that second result. We have to show that the expected value of SST, that is the sum of square due to treatment, is nothing but this term. Okay. That means we are finding expected value of the error sum of square due to treatment. And in that scenario, we are required these two results. ये results का import. That result we are going to use. Their mean and variance. So that's why we have just computed that quantity. So as usual, there are the formula y bar dot and this. So y bar dot you can have this, y bar dot dot you have this, right? This already you have computed. So you can just maybe we can get cancel alpha I plus e bar I dot minus e bar dot dot. What is the remaining term? You can write it down. Now you can open the brackets, right? You can open the brackets, assuming that this is my A, this is my B. Okay, A square plus 2 times AB plus B square. And if you just look at this, take expectation both the sides. If you just take expectation both the sides, just try to understand these terms are very, very important. If you just look at the second term, mean of this particular brackets, we have just seen iska mean and iska mean is coming 0. So 0 minus 0, 0. That means this term goes 0, right? This term becomes 0. So if you just take expectation of this term, expected value of constant is constant, so it is going to be this one. This term is become 0. And what about expectation of this value? Just try to understand. Expected value of double summation e bar I dot minus e bar dot dot इसका square है, right? Because we have this term square. Now can you tell me what is your variance of x? It is the expected value of x square minus e of x ka whole square. So now I have this term. So what I can write? Variance of x plus expected value of x ka whole square equal to expected value of x square. So this term now can be written as this plus this. So same thing I'm now trying to write it down in terms of, can you look at here? Can you look at here? This is what they have written. This is what they have written. Standard results just now seen. What is the result? ei bar dot square minus e of dot dot square. The middle term goes 0, right? It goes 0 or it goes 2 times that just now seen y minus y bar. इसका क्या होता है? Sorry, this dot will not come. क्या होता है इसका? Summation y square minus what? N time y bar square. But what is the n bar? Summation only, right? This is summation only. So they have written in terms of summation only. So this is nothing but what? Variance expected ka whole square. This result. So this result we have used here. Again, in this case also we have used same result. Okay. What is the variance of EI? Sigma square. Mean 0. Mean 0. Correct? This variance become divided by n. Get simplified. Further simplified and get cancelled. What is this quantity? This is get cancelled. Summation is independent. So k times sigma square. Here we left with sigma square. This difference is k minus 1. And summation over j is independent. So ni alpha square plus k minus 1 times. Hence, one can prove. So hence it is proved. So this is all like a very simple results which you can use it. You can like looking as a previous derivations, one can able to find out their expected value, which you need to use it for your like practical purpose. Okay. So sometimes they will ask you compute the expected value. So for that purpose, you need to like use that concept. Exactly the same way you may try out the summation 9 alpha square. Okay. And next class you tell me whether you can able to do it or not. And similarly you can try out expected value of e square and let me know whether you can do it or not. And then I will be do the testing part. Means this is we have already seen like degree of freedom. So using Cochrane, as I mentioned, like we can use it Cochrane concepts. So Cochrane कैसे use होता है that we will see in the next class. Okay. So till here you can try to see, and if we have any questions, maybe when you just go through these notes, then we will do it in the now next session will be like we have a 4 o'clock, but I think 4 o'clock you already knowing that we have a guest lecture, so you can just join the guest lecture for today workshop.